Good morning to all. This is first lecture on functions or mapping. This is very next topic of relation. As you have already done the topic of relation, we are doing function as a special case of relation. First of all, a function or mapping. Mapping is another word for function. So a function or mapping is a special case of a relation. Now we are defining function. How? It is a function is a relation from a set A to a set B, so that function is defined from one set to another such that for every element A belongs to A, yani for each element of first set there is some unique element in the second set such that B is equal to FA. B is equal to FA means A की जो इमेज है वो B है, B को इमेज कहा जाएगा A की और A को प्री इमेज कहा जाएगा B का. यही बात यहाँ लिखी गई है. इसी तरह जो A सेट है, द सेट A विल बी कॉल्ड डोमेन ऑफ F, वेयर एज B इज कॉल्ड को डोमेन ऑफ द फंक्शन. नाउ फर्स्ट एग्जाम्पल इज गिवन, दैट इज 9.1. उसमें कहा गया कि F is 1A 2B 3C. So that means 1 has image A, 2 has image B and 3 has image A. So that we are saying if domain is 1 2 3 and range is ABC, then every element of set A has a image, has a unique image in set B, so that we are saying that this is a function. Now next in 9.2 what we are given, a function f such that 1 has image A, 2 has image B, 3 has image C, 1 has image B, so that you are saying that 1 has image A and B, so that 1 does not have unique image, hence this example is not representing a function. Now we are saying representation of a function by a diagram. We are saying that if A domain set is A1 A2 A3 A4 and codomain is B1 B2 B3 B4, then we can say that if a function is defined from A to B, so that each element of set A is related to some element in B and each element of A has unique image in B. So that we are having some examples whether they are a function or not. So A, that is first part, you are saying that each element of A has a unique image in B, so that F1 is a function. F2 you are saying that A1, small a1 has two images, one is B1 and other is B4, so that it is not a function. F3 is again having unique image, but A4, the one element of domain A4 does not have any image in set B, so that F3 is not a function again. Now we are defining some functions. First is constant function. Constant function means every element of domain has a fixed image, that is constant image, so that exactly one element is a image and there are many pre-images, so that all the elements of domain is related to a fixed element, a single element of B, so that it is called a constant function. One example is given, so that each and every element, that is 0 2 pi 4 pi, will give same value, that is 1 on each of these points, so that function is constant function. Next is identity function. Identity function, you are saying that element is mapped on itself, so that fx is equal to x for each element of x, each element x of A, so that this kind of function will be called identity function. Next is equal function. Equal function, two functions will be called equal function if first is domain of them are same, next is codomain will be same, and third is f1 is equal to f2 for every x belonging to their common domain. So that one example is given, range and domain and codomain are given, two functions are defined. Now we are saying that for each value of x belong to A, we are having same value for both the function. Hence, these two functions will be equal function. Now next is types of function. Types of function, first is one function. One function, it is also called injective or injection. It is simply if it is a1, then if images are equal, then elements are also equal. Otherwise, if elements are not equal, images are not equal. This is called one function. One example is given, and f from r to r in a part, it is fx is 2x, so that is function is 1. So any real number you are putting in place of x, we are getting a different image, so that if elements are not equal, then images are not equal in this case, so that this function is 1. And b part, f is n to n, that is fx is 2x square plus 1, so that we are saying that 2 and minus 2 will have same image, so that it is not 1, so that one element is not mapped onto the one element. Next is many one function. Many one function means if elements are not equal, means many elements can be mapped to one element, so that if elements are not equal but images are equal. So one example is given, that is 4x square plus 5. इसमें आप देख पाएंगे कि a और माइनस ए कोई भी रियल नंबर अगर आप पॉजिटिव में रखें और नेगेटिव में रखें विल गिव सेम वैल्यू, सो दैट इट इज many to one function. Next is onto function. Onto function is agar if each and every element of set B, that is codomain set, has a pre-image, since it is not necessary condition for a function, but if you are saying that every element of B is also has pre-image in A, then the function will be called onto, so that range and codomain in that case will be same. Next is into function, which is opposite of onto function, means there is some element left in the codomain set, so it will be called into function. Fine. Next is bijection or bijective function. Bijective function say if a function is 1 and onto both, so that it is called 1 onto or bijection. One example is given, it is very important thing. So one example is given, it is 1 and onto, that is fx is x plus 1 is 1 and bijection also. So if a function having both the property of 1 and onto, then it will be called bijection. Inverse of a function. Inverse of function, if f is defined from a to b, then and it is a bijection function, then an inverse function. Remember, bijection, in case of bijection, we can define inverse function from b to a. So b to a will be defined as f inverse. F inverse from b to a, you can say that in this case, domain of function f will be treated as codomain of f inverse and vice versa. So that this is one example for inverse function fc. This is a well-known relation between Fahrenheit and Celsius, and you can see fc, f in terms of c is given, so that c in terms of f will be the inverse function of the above function. One theorem is given, if f is 1 onto function, then inverse is also 1 onto. The proof is given for your kind reference. Now composite of function. Composite of function, you are saying that if function f is defined from x to y and another function is defined g from y to z, then we can define a composite function from x to z, that is GOF. That will be called composition of f and g. Composite of function will be defined as GOFX, which will be treated as g of fx for all x belongs to x. This function it will be defined from x to z, that is first set to third set. Fine. And one example for composite function is given in this case. You can understand this. Look at this. F O G X means f of gx. So first gx will be put, then definition of fx will be written. Similarly, g of fx will be g of fx. Similarly, f o g5 will be f of g5, and g o f16 will be f of g of f16. Hope you understand this. Thank you.